For the final project, I chose to build upon the code for the deliverable project, Daddy Longlegs. Based on my observations from that project, I decided to ask the following question. For a fixed computational budget, does the quadruped evolve to move further with the ability to mutate both the upper and lower halves of their legs, or with the constraint of moving just one half? To show the evolution present, I'll be showing random selections of the robots with the ability to mutate both their legs, then of just the upper legs and just the lower legs. Following these selections, I'll show clips of their respective evolved solutions. And to start, we'll look at this random selection and evolved robot with the ability to mutate both of its legs. This is something that anyone who completed Daddy Longlegs should be familiar with. You can clearly see the difference between the first randomly selected run and the final evolved robot. Just some background information. Both the population and generation sizes were set to 10, while any mutating legs were allowed the range of 1 to 3 to choose from. Then we move on to the robot that is only allowed to evolve its upper legs. In the first iteration, the random sample, we can observe that the robot practically refuses to move, indicating that, as far as we can tell, this is not more efficient than both legs being able to mutate. However, when we see the evolved state of this iteration, our suspicions are confirmed. After 10 generations, this robot still does not want to move. The robot just kind of hobbles a little and then gives up. Finally, we get to see the robot that has the ability to move solely its lower legs. The random selection that we see here does not go very far. It starts walking, then like the last robot, it also gives up and stays frozen. However, the evolved robot does a very good job of moving far and fast. If I continued on with this project next year, however, I would love to experiment with different value ranges for the legs to choose from, and add functionality that would also respond to any robots that fell over. If we were to graph these 3 runs, this would be the graph that we would see. The robot that could move only its lower legs outperforms both the other robots with an overall fitness mean curve that resulted in a smaller fitness value, which was what we were looking for. So the answer to my question is no, the robot does not need the ability to mutate both its legs to perform well. Thank you.